This lesson is on choosing strategies for solving systems of equations. You have 4 methods to solve systems of equations. Use the graphing method when you want a visual understanding of the solution as a point of intersection. When one equation is already solved for x or y, you would want to use substitution. In other words, when one of the equations reads x equals or y equals, use substitution. When the coefficients of one variable are opposites, or if they match and can be easily made opposites, use elimination using addition. And when no corresponding coefficients are opposites, we'll have to solve by elimination using multiplication in order to create opposites. So suppose you had to choose the method to solve 2x minus 3y equals 4 and 2x plus y equals negative 4. The first thing I hope you notice is that we have a column of x's, a column of y's, and a column of numbers. That suggests we're going to use one of the elimination methods. So let's look at the coefficients. On x, we have coefficients of 2 and 2. Now those aren't opposites, they match. But we could easily make them opposites by maintaining the first equation and taking the opposite of every term in the second equation. So the 2x becomes a negative 2x, the positive y becomes a negative y, and the negative 4 becomes a positive 4. So now that we have created opposites on our variable x, we should solve this by using elimination using addition. The 2x and negative 2x add up to be 0, and so the x's are eliminated. Negative 3y plus a negative y gives us negative 4y, and 4 plus 4 adds up to be 8. So dividing both sides by negative 4, we get that y is equal to negative 2. Now we'll substitute that into one of the original equations. I'll pick the first one and solve for x. So we're going to plug in that y is negative 2. Simplifying, negative 3 times negative 2 is a positive 6. We'll subtract 6 from both sides. That gives us 2x equals negative 2. And dividing by 2, we get that x is negative 1. So it appears as our solution has an x-coordinate of negative 1 and a y-coordinate of negative 2. But we can check that in the second equation to see if it holds true. So we'll plug in the fact that x is negative 1 and y is negative 2. That gives us negative 2 plus negative 2 equaling negative 4. And since negative 4 does equal negative 4, our solution satisfies both equations. Let's try another example. Suppose you had to solve y equals 2x minus 6 and x plus y equals 9. I hope you notice that our first equation reads y equals. That suggests that we should probably solve this by substitution. So we'll begin by separating our two equations in a T-chart. Now because our first equation read y equals, that's telling us that y can be replaced by 2x minus 6. So we go over to the other equation and make that substitution. Y can be replaced by 2x minus 6. Combining like terms, we get that 3x minus 6 is equal to 9. Add 6 to both sides, 3x equals 15, and divide both sides by 3, and we get that x is 5. Now that says wherever there's an x, we can replace it with 5, so we'll go to the other equation and make that substitution. That gives us that y is equal to 10 minus 6. That y is 4. So our solution appears to be 5, 4, but we can test and make sure that it works in both equations. So substituting 4 in for y in the first equation, 2, and we're going to plug 5 in for x. We get that 4 is equal to 10 minus 6. 4 equals 4, so it checks in the first equation. Let's try it in the second equation. We're going to replace x with 5 and y with 4. And since 9 equals 9 is true, it satisfies the second equation. Our system solution is 5, 4.